Now we are going to look at scenario 3. We will begin with step 1, where we write our hypotheses. The null hypothesis is still that mu, the population mean, is equal to 43 grams. The alternative hypothesis here, I will go over to remind us of what's happening in scenario 3. This person just thinks the mu is something other than 43 grams, and they got that their X bar was 42. So their alternative hypothesis is that mu is not equal to 43. Notice there is no inequality symbol in this alternative hypothesis. There is a not equal to. Whenever that happens, that is when we have a two-tail test. Our rejection region picture will have two rejection regions as opposed to just one, as we saw when it was all on the left and when it was all on the right. Step 2 here, we will calculate our test statistic. We're still using the formula that z is equal to x bar minus mu divided by sigma divided by the square root of n. Here x bar is equal to 42. Mu is still 43. We can look at the null hypothesis to see that. Sigma is still 12 and the sample size is still 100. This comes out to give us a -1 divided by 1.2, which gives us a test statistic of -0.833 when we round that to 3 decimal places. Now for step 3, we will draw our rejection region and determine what our critical values are. I will start off by drawing a bell curve. This is a two-tailed test, so I'm going to have two rejection regions, one to the left and one to the right. Alpha is still equal to 0.05. Remember, that's something that will be given to us. And this needs to be shared in between the two tails. So this 0.05, or alpha falls, is the area of the rejection region. So one tail has an area of 0.05 divided by 2. I'm sharing that total alpha area between those two tails, which tells me that one tail has an area of 0.025. So there is 0.025 in this tail and 0.025 in that tail. So now I am going to use the fact that now I know the left area of this critical value here to go to my statistics tables and find out what exactly my critical value is. So I'm looking for a z-value with a left area of 0.025. And so in looking at that table, I see that right here, 0. Okay, there we go, 0.025, and that is at -1.96. So our critical value, or our critical values, we have two in this case. A two-tailed test has two critical values, are positive and negative 1.96. Remember, there's symmetry here. So once we find one, we just have to change the sign to find the other. So now that we have our rejection region set up and we know our critical values, we're ready to move on to step 4. I will take the test statistic of -0.833 and drop that into my picture. -0.833 is bigger than -1.96, but smaller than positive 1.96, and so this does not fall into the rejection region. And so our decision for step 4 is that we fail to reject HO. The test statistic does not fall into the rejection region. So since that does not fall into the rejection region, we are failing to reject HO. So I'm not going to cross out HO. I am instead going to cross out HA. Now we are ready to move on to step 5 and write our conclusion. Our level of confidence is still 95% because our alpha level of significance is still 5%, 0.05. So we are able to say that with 95% confidence, remember, we have failed to reject HO. So in reality, we are rejecting HA. Our conclusion needs to be written in the context of HA. So we are saying there is not enough evidence to support HA. So there is not enough evidence to support that the population mean weight of a candy bar is different than 43 grams, because that's what HA said. Remember, HA was that mu is not equal to 43 grams. So since we have rejected HA, we're saying there is not enough evidence to support that the population mean weight of a candy bar is different than 43 grams.